can't go over something. It's been a long time since I've seen that. Yeah, with Eddie Murphy? Yeah. It's been a really long time since I've seen that. So how are we doing? So y'all, did y'all introduce yourselves? I didn't see you talking.
Wait, Erin. She's in all my classes.
Well, why aren't y'all talking? You can help each other, you know. Did I tell you how to be quiet this whole class? Did I? Which one are you stuck on? The middle one. Okay. Well, let's do the first one first. We'll do the middle one last then. How's that? Because it's the hardest one, evidently. Okay, when I do put this in my calculator, it comes out to this, right? Well, let's look at it. Let's circle. This is in a ones place. This is in a tens place, right? So we can only report to the tens place. So we get rid of that 8. The 8 makes the 0 go up, doesn't it? But we have to put a 0 there. Now the 0 is not significant. It's just a placeholder. So the answer is 1110. Okay? This one over here. 0, 0, 400. They're both in the ones place, aren't they? Mm-hmm. So that should be easy. What do we do? Now, that made that ones place significant. Okay? The one in the middle. Well, let's add. 9, 8 and 4 is 12, carry 1, 8, 5.829. Okay? Let's circle the last significant digit. So, I can only report to right here. So I gotta get rid of that 9. 5.83.
Could you say that again?
On the middle one?
Yeah.
Okay. Is this what you got? 5.829?
Yeah.
Now look, I circled the last significant digit in each one of them, right? And so it told me I could only come out here to this, to the hundredths place, right? So I have to get rid, right, of everything over here. Got to go away. Well, this first digit that I'm getting rid of is 5 or greater, so my rounding off rules tell me that that 2 goes up to a 3. And this becomes 5.83. Yes? No? Yes?
I understand it, just have to
Process it and practice it.
Yeah.
Guess what? There's plenty of practice in the homework. Who's done some of the chapter 2 homework? Okay, good. Right, it's not even due this week. It's not due till next week. The other class, they asked me, they said, well, you said there's going to be quizzes. Yeah, the quizzes will start with chapter 2, okay? Because we're not finishing chapter 2 today, okay? Does that make sense right there? So another good example of this is in the lab, we'll do some stuff that'll be like 53.4 minus, oh, I don't know, 3.4. What do you have? This is 50, right? 0.0. And that's important because it tells people you made this measurement precisely. It's like the difference between saying, oh, that person's about 200 pounds, go calculate the dosage, or no, that person weighs 189 pounds. Right? you can calculate the dosage much more precisely. For some medications, that can be important, right? That's a big dog. He's about 75 pounds, or he's about 100 pounds. Well, 75 rounded off, could be 100. Get it wrong. Is he 80 pounds? Is he 70 pounds? Is he 100 pounds? The more precise you can be in your measurements means you can have more confidence in things like that, in your dosages and stuff when you calculate them. Okay? Fair enough? So we're all kind of sort of okay on significant figures and stuff, adding, subtracting, multiplying, dividing. Okay, there is practice on the homework. And how do you, if you struggle with the homework, what are you going to do? Email me or come see me, right? If you're, I know you guys are in the science building, I've seen you up there, right? You know where my office is, right? No?
On the top floor.
You know where the computer lab is in the science building?
But you have it written down on here. I can find it.
Well, I know you have class right across from my office. I've seen both of you.
Oh, okay. Trust me, I will be busy.
No, that's all right. No, it's okay. The less you come see me, the less I have to do, you know? It's okay.
You're gonna have plenty to do, trust me.
I'm just going to save this file and then I'm going to open the slides. That's all I'm doing, okay? So, today's date? 1/20/16. Well, it's not fall. I think I just saved that one for fall. Yep. Well, all right. Let's see what we do here. Here we are. Slides. We're going to cover just a little bit. We're not going to get to doing conversions today, but we're going to get close. How's that? Okay, so the next section of your book is titled Equalities and Prefixes. We talked a little bit about prefixes the other day, and we're going to talk more about them today. So in science and in the metric system, we have our base sets of units, right? Mass is grams, length is meters. Well, because we don't have gallons and pecks and cups and pints and all that kind of stuff, right? See, in the English system, what do we have to do? You have to know, what, 2 cups and a pint? 2 pints and a quart, is that right? 4 quarts in a gallon? How many gallons in a peck? How many pecks in a bushel? You gotta know all this stuff, right? Or we'll do some easy ones. How many inches in a foot? 12. And how many feet in a yard? How many feet in a yard? 3. 3 feet in a yard, right? Y'all don't even know that.
We know this.
Come on, guys. Y'all know these things. Now, I don't know about pecks and bushels and all that, but 3 feet in a yard, we know that. But wouldn't it be much simpler if we had a way, instead of having to multiply by 3 or divide by 3 or whatever, if we could just move the decimal around kind of occasionally? Makes your calculations and stuff easier, doesn't it? Okay? Well, that's the beauty of the metric system. It is factors of 10, or one of the great things about it. And the way we designate these factors of 10 is by prefixes. And we've talked about some of them already. We talked about kilometers, right? Capital K. Well, here's some small units, milligrams and micrograms. Okay? These are things that are smaller than a gram. A microgram's tiny. Okay? Here are some of the units that are bigger than the base unit. You guys probably know all these units. Well, that's interesting. Ooh, it just did something I didn't want to do. It tells me I'm writing in black, and it makes a red line on the screen. That's interesting. Okay? These units are all bigger than the base unit. Yes, ma'am? Yeah, you don't have to ask. So, how do you guys know these units? Kilo, mega, giga, tera. Where do you know these units from? Yeah, bytes. Bytes of memory from your computers, right? So, I always tell a story. The first computer I sat down at was like a Commodore 64 because it was 64 kilobytes of memory. Now on your cell phone, you get gigabytes of memory on your cell phone, don't you? And terabytes on your laptop, right? That's not it. Well, I guess it's a few years ago. That's since like the 80s, right? I know y'all weren't born yet, some of you. Some of you. Some of us were, right?
Yeah. Good old days.
Some of us were just babies and didn't know anything in the 80s. Some of us were college and stuff in the 80s. So these numbers are big numbers, right? Kilo means, the one you really need to know is kilo. It means 1,000 of something. So if I have a kilo students, I have 1,000 students. Okay? No matter what the unit is, if you have a kilo of it, you have 1,000 of them. So a kilogram, a kilometer, kilosecond, whatever the unit is, kilo means you have 1,000. Okay? The other ones, if you need them, you can refer back to your book. Fair enough? Now, a small units, deci, centi, milli, micro, I'm going to use them a little bit different than they use them in your book. I'm going to say that there's 10, 100, 1,000, and 1,000,000. So there are 10 decimeters in a meter. There's 100 centimeters in a meter. There's 1,000 millimeters in a meter. There's 1,000,000 micrometers in a meter. How many microliters in a liter? 1,000,000. That's what the prefix micro means, right? And micro is the one with the weird symbol, this little Greek symbol, nu. Okay? Fair enough?